Hello and welcome. Today we're going to continue our discussion on reducing rational expressions. In our previous lessons, we've discussed reducing rational expressions by factoring completely and identifying common factors between the numerator and the denominator. In today's lesson, we're going to move on into division, so taking two rational expressions and dividing them. First, let's recall simplifying expressions with multiplication. So looking at this first expression, I'm going to look at each fraction individually and reduce from top to bottom if possible. On the left, there are no common factors between the numerator and the denominator, but on the right, I may reduce my 2's, leaving me with a 1 on top and just an m on the bottom. Now I multiply across. 2 times 1 is 2, and on the bottom, 3 times m is 3m. Looking at this expression, I cannot reduce any further, so this is the most reduced form of my original expression. On the right, again, I look at each individual fraction and reduce as much as possible if I can. On the left, I can reduce my a's and the numerator and the denominator of both. And on the right, I may reduce my 3's. Multiplying my numerators, 3 times a is 3a, and my denominators, I just have a 2, and what's left on the right is a 1, and 2 times 1 is 2. So the most reduced form of my original expression is 3a all over 2. Now down to the left. First thing I need to do is factor everything completely in order to identify common factors. Please remember that you may not reduce unless it is multiplication. Because there are addition and subtraction signs, I may not reduce, for example, these p squareds. Since there is addition and subtraction, I must either reduce this entire polynomial or nothing at all. So I am going to factor first. To factor this top numerator on the left, I will use the diamond method. However, I'm just going to jump straight to factored form. You can practice the diamond method on your own. You should have p plus 3 times p minus 1 all over, and on the bottom I can take out a 3p squared, leaving me with 2p minus 3, and on the right I can factor out again a 3p squared, leaving me with 3 minus 2p. On the bottom I can only factor out a 2, leaving me with p plus 3. So looking from top to bottom of each individual fraction, I identify any common factors if there are any, but there are not, so I instead reduce diagonally. I see a p plus 3 on the top and the bottom, so I cancel these out. I also see a 3p squared that I can cancel out. And this next factor, 2p minus 3, is repeated on the top right, except that everything is backwards. I have a positive 2p and a negative 3, and on the top right I have a positive 3 and a negative 2p. So when I reduce these, I end up with a negative 1 instead of your traditional positive 1. Since all of those factors are reversed, it reduces to a negative 1. So now what I have left is a negative 1 and a p minus 1 on the top. And in my denominator, the only thing that has not reduced is a 2. Simplifying, I'll distribute that negative 1 to get negative p plus 1 all over 2. To the right, again, we factor each of our numerators and denominators completely. P minus 1 cannot be factored, but the denominator may be factored into p plus 2 times p minus 1 times, on the right, this factors into p minus 3 times p plus 2. And the denominator, you should be able to recognize as the difference of squares. P squared minus 1 is also p squared minus 1 squared. Since I have the bases being squared, I take those bases and add them to get p plus 1 and subtract them to obtain p minus 1. Now I look at individual fractions and cross out any common factors between the two. I see a p minus 1 repeated in the left, and on the right there are no common factors between the numerator and the denominator. However, I do see a p plus 2 repeated in the numerator on the right and the denominator on the left, so I may cancel these out. Nothing else reduces, so this leaves me with a p minus 3 over p plus 1 times p minus 1. To simplify completely, I'll go ahead and FOIL out this denominator, first distributing my p and then distributing my positive 1. After FOILing, I will obtain p squared minus 1 in the denominator, and you can complete that FOIL process on your own. Now we're going to go into division of two rational expressions. Now remember, dividing by a fraction is the same as multiplying by the reciprocal. What this means is if I have a fraction and I am dividing by a second fraction, instead of dividing, I am going to take the reciprocal of that second fraction, so flip it over to 7 over 4, and change my division to multiplication. From here, I reduce if possible, and multiply. I can reduce my 2 and my 4, and then multiply my numerators. 1 times 7 is 7, 5 times 2 is 10. We cannot reduce any further, so this is the most reduced form of your original expression. On the right, same thing. I'm dividing by a fraction, so I'm going to take the reciprocal of that second fraction and change my division to multiplication. This first fraction stays the same, my division becomes multiplication, and I reciprocate or flip over the second fraction. So I now have 27 over 14. Before I multiply, I'm going to reduce as much as possible. 7 becomes a 1 and 14 reduces to a 2. 9 reduces to a 1 and 27 reduces to a 3. Now multiplying across, 1 times 3 is 3 and 1 times 2 is 2 in the denominator. On the bottom left, now there are some variables in my first fraction, but this does not change the process. Since I am dividing by a fraction, I will again multiply by the reciprocal. So my 5x over 3x stays, but my division changes to multiplication, and my second fraction reciprocates, or becomes 4 over 5 instead of 5 over 4. I now reduce as much as possible, and then multiply across. My x's may reduce, and I may also reduce my 5's on the top left and the bottom right. These both become 1's. I cannot reduce any farther, so I multiply across. 1 times 4 is 4, and 3 times 1 is 3 in my denominator. Be sure to verify that we cannot reduce any farther, and we are done. Last on this slide, my 5x to the 5th remains the same over 4x. My division changes to multiplication, and I reciprocate or flip over the second fraction. So I now have 4 over 3x squared instead of 3x squared over 4. And now I will reduce as much as possible. I have 1x on the bottom and 5 on the top in the fraction on the left. So all of the x's on the bottom go away, while those on the top become x to the 4th. I can reduce these even farther with the x to the second on the bottom right. So all of the x's to the second go away, and this x to the 4th decreases by 2 and is now x to the second power. I also see my 4's that can reduce to a 1 and a 1 on the bottom left and the top right. And now I multiply across. I have a 5, an x squared, and a 1 on the top. Multiplying these all together, I have just 5x squared. And in my denominator, I have a 1 and a 3. Multiplying those, I just have a 3. Again, be sure to verify that you cannot reduce any farther, and you are done. We're going to extend these into a more advanced type of polynomial. So now, in this case, all of these have been factored for you, and we are going to identify common factors that are binomials in each of our polynomials. However, first, since we do have division, I am going to flip these over and multiply. Remember that your first fraction does not change, so we still have r minus 2 times r plus 3 all over r minus 2. My division changes to multiplication, and I reciprocate or flip over the second fraction, so I now have 6r over r minus 2 times r plus 3. Now that I am multiplying, I identify common factors between the numerator and the denominator before I multiply. I see r minus 2 repeated in the numerator and the denominator of this fraction on the left, so I'll cross those out. I see an r plus 3 on the top left and an r plus 3 on the bottom right, so I may reduce those as well. The only thing that I have not reduced is the 6r in my numerator and the r minus 2 in the denominator. Again, be sure to verify that you cannot simplify any farther, and you are done. Please remember that you may not reduce these r's because that minus sign on the bottom is glued to the r. These two things may not be separated, so we cannot reduce any farther. On the right, I will repeat this process. Remember that the fraction on the left does not change, so I still have 2 over a plus 1, a minus 1. But on the right, I change my division to multiplication and reciprocate the second fraction. So the denominator comes to the top and the numerator drops to the bottom. Before we multiply, let's reduce as much as possible first. I see an a plus 3 repeated. I can cross those out. And on the top and the bottom, I also have a minus 1. The only thing left that has not been reduced is a 2 in the numerator and an a plus 1 in the denominator. Go ahead and pause the video and try the next two on your own. On the bottom left, I would like to point out that there were two opposite factors you needed to reduce to a negative 1. There is a factor of 2 minus n and another of n minus 2. These are exact opposites, so when I reduced them, I was left with a negative 1. When I was done, I took that negative 1 and I distributed it to the other polynomial, leaving me with negative n plus 1 over 2 plus n. On the right, you should have 3a all over a minus 3. On this next slide, we need to factor before we flip and multiply. So first thing I'm going to do is factor this numerator on the top left. To do that, we would use our diamond method, but I'm going to go ahead and go straight to factored form. You should use your diamond method to practice this work. We have k minus 3 and k plus 2. In our denominator, I can factor out a GCF of 2k, leaving me with k plus 2. On the right, I'm dividing by k minus 3. I cannot factor that any farther, but our denominator can factor out a 3, leaving us with k minus 1. Now I flip and multiply. My left fraction stays the same. I still have k minus 3 times k plus 2 all over 2k times k plus 2. My division turns to multiplication and I reciprocate my second fraction. Now before I multiply, I identify and reduce any common factors. I see k plus 2 repeated, those are identical, and k minus 3 repeated. I do not see anything else repeated. So in my numerator, I have 3 times k minus 1, and in the denominator, 2k. I'll distribute this 3 to simplify completely, and then we are done. Go ahead and take a moment to pause the video and try the next 3 on your own. First, you should have 6 over n minus 2. On the bottom left, everything canceled, leaving you with just a 1. And to the right, there was one factor that was opposite of the one on the denominator, so I reduced those to a negative 1, and everything else reduced to a 3, so I was left with negative 3. This last slide is extra practice. Please go ahead and pause the video and try the next 4, and in just a moment, I will show you your answers. Go ahead and check your answers. Be careful to watch for those opposite factors. In the second, third, and fourth problems, you did have opposite factors that you needed to reduce to a negative 1. So be careful of those and remember to distribute at the end. Thank you so much for watching. I hope you enjoy the rest of your day.